In this lesson, we factored some more complicated looking expressions by looking for and making use of their structure. So in these four problems here, we need to make sure we truly understand how we can factor things by looking at its structure. So factor the following polynomials completely. Big surprise with those directions there. So number one, I have y to the fourth minus 21y squared minus 100. So it's a trinomial. And I like that the leading coefficient's 1, because I don't have to go through and do the whole AC method. I just need to ask myself, what multiplies to 100 that adds to negative 21? Multiplies to negative 100. What multiplies to negative 100 that adds to negative 21? Well, I'm thinking that's the numbers negative 25 and positive 4. So this factors as, well, it's not just y in the front seat of both of these binomials, it's going to be a y squared to get that y to the fourth term. Minus 25 plus 4. Well, wait a minute, y squared minus 25 is the difference of perfect squares, so I can factor that as y minus 5, y plus 5, but I can't currently factor y squared plus 4, so we will leave that alone. And that's how we factor that polynomial completely. Not too bad. Not too bad. But don't panic. It's a trinomial, so when we factor trinomials, we have to use the AC method or that add multiply rule. Number 2. Alrighty, n to the 6th minus n to the 4th minus 16n squared plus 16. Well, I've got 4 terms, no GCF, so I'm definitely going to have to try grouping. 4 terms means I'm grouping. So what can I take out for those first 2 terms? I can take out an n to the 4th, and I'm left with n squared minus 1. Hopefully I can get n squared minus 1 over here. Well, what do I need to factor out then? A negative 16. So I'm left with n squared minus 1 times n to the 4th minus 16. Well, wait a minute. Both of these are the difference of perfect squares. So I get n plus 1, n minus 1. And then I get n squared minus 4, n squared plus 4. And oh my goodness, look what we've got again, the difference of perfect squares. So my final answer is n plus 1, n minus 1, n plus 2, n minus 2, and then we've got this quadratic that's irreducible. We can't factor it anymore over the real numbers, so we leave it alone. This expression is equivalent to this polynomial here. That 4-term polynomial is equivalent to the product of these 5 factors. They look different, but they have the same value. Number 3. Alrighty, I've got 2x squared minus 7x squared minus 2x squared minus 7x minus 12. This looks weird, and it's very tempting to square it, distribute that negative 1, but don't. Look for and make use of the structure of it. I have something squared minus that same thing. Something squared minus that same thing minus 12. How do I factor? This is really just a trinomial. This is a trinomial, but instead of just having a plain old x, I've got that chunk 2x squared minus 7x in place of that x. Well, I know how to factor this trinomial. That is what multiplies to negative 12 that adds to negative 1. Well, that's going to be n minus 4, n plus 3. But what was n? N was taking the place of that chunk, something squared minus that same thing minus 12. So n is really 2x squared minus 7x minus 4. Replacing n there, 2x squared minus 7x plus 3. So now I've written that expression as the product of 2 quadratic factors. Can I factor those quadratic expressions anymore? So they're trinomials. There's no GCF, so it looks like we have to use the AC method. We need to stop and ask ourselves, what multiplies to a times c, negative 8, that adds to negative 7? What multiplies to negative 8, that adds to negative 7? Well, that's going to be negative 8 plus 1. So I split up that middle term, 2x squared minus 8x plus 1x minus 4. Group now. X minus 4 I need an x minus 4, so what do I have to factor out? Just a 1. I don't really need to factor anything out there. So I'm left with x minus 4 times 2x plus 1. Those are the two linear factors from that quadratic factor. And let's repeat the whole process here. What multiplies to 6? That adds to negative 7. Well, that's negative 6 and negative 1. Split that middle term. 2x squared minus 6x minus 1x plus 3. Now that I've written as 4 terms, we group. I need an x minus 3, so I'm taking out a negative 1. So I'm left with x minus 3 times 2x minus 1. So, what is my final answer? My final answer. This expression that we started with at the top here, that crazy one, is actually equivalent to x minus 4 times 2x plus 1, those were those two linear factors, times x minus 3 times 2x minus 1. It's written as the product of those 4 linear factors. We looked at and made use of the structure of recognizing it's really a trinomial, but it's not just a plain old x. It's got this chunk, 2x squared minus 7x. And then, because this problem's fantastic, we got to apply the AC method twice to these quadratic factors. And finally, we end over here with 8x to the 6 plus 7x cubed minus 1. I don't see any GCFs. I realize it's a trinomial, so I'm going to use the AC method. I'm going to ask myself what multiplies to a times c. What multiplies to negative 8, that adds to 7. Well, how can I split up 7? How about positive 8 and negative 1? So I split that middle term. 8x to the 6th plus 8 what? Well, that was an x cubed term. That doesn't change. Minus 1x cubed minus 1. Now we group. I'm going to take out an 8x cubed. And I'm left with, well, what times 8x cubed gives me 8x to the 6th? That's going to be an 8x cubed plus 1. I need an 8x cubed plus 1 over here, so what do I factor out? I need to factor out a negative 1. Finishing up grouping by taking the GCF of those two terms now, I get 8x cubed plus 1 times 8x cubed minus 1. And great, you factored that crazy trinomial, but look at both of those binomials, those factors that we were left with. I've got x cubed plus 1. That's the sum of perfect cubes. And then I've got 8x cubed minus 1. That's the difference of perfect cubes. Well, let's factor the blue one first. Let's factor x cubed plus 1 first. The linear factor is x plus 1. It's the quadratic factor that we need to remember. And remember, when we factor perfect cubes, we square the first thing, x squared, minus their product, minus 1x, plus square the last. 1 squared is 1. Then for the red term, what's the linear factor? What gave me 8x cubed? Well, that's going to be 2x. What gave me 1? 1. So 2x minus 1 is the linear factor. The quadratic factor is going to take a little bit more work. Who goes in the front seat? We'll square that 2x. 2x squared is 4x squared. Opposite sign, their product, plus 1 squared is 1. So that is how we factor this expression completely. I snuck in the sum and difference of perfect cubes on you at that last step. So first you had to factor the trinomial, probably using the AC method, and then I threw in perfect cubes in there. And this is as crazy as factoring gets, and we put a halt to it here. We don't factor any more crazy extreme expressions. However, we can extend this idea. We can substitute in things so it's not just x. We can throw in perfect cubes after grouping. So keep all of those factoring methods in mind because they are all fair game. So finally, in the next lesson, we put factoring to use by solving polynomial equations. Of why have we been factoring? We use factoring to solve polynomial equations. See you in the next video.